Hi, good day. I'm Sil. I'm the product manager for Solidworks Simulations. Again, welcome to IME webinar. Today topics: predict product defect for transportation innovators. For those who joined my sharing last week, this is the part 2 of Solidworks Simulations for transportations and mobility. Without further ado, let's start with today's agenda. First of all, assembly deformations and safety factor study. Then we talk about optimizing the design. And next we have mechanism study. And of course, one of the designer concerns is to predict design lifespan. And last but not least, something a little bit more advanced on CFD we call aerodynamic study. So you can see there's two nice image on the right. So this is actually a brake design, a brake caliper design, where we would like to study the stress on the knuckle. So the right image show the stress deformations, and the color plot indicate high stress area and low stress area. In general, SolidWorks simulations split into three types of simulations. We have the finite element analysis, or we call SolidWorks simulations. And then we have the CFD, computational fluid dynamics, where we can perform internal, external flow, laminar, turbulence flow. And last but not least, we have the soluble plastic, where we use to predict the plastic injections for plastic design. As for those who joined my previous sharing, last meeting I have covered solid simulations and soluble plastic for those who have interest in plastic part design. As for the part 2, again I will emphasize on SolidWorks simulations, and this time we have the additional flow simulation as the sharing. First of all, what SolidWorks offer for simulations? So this is the list of all features that we offer in SolidWorks simulations. And for transportations and mobility, or I will call the automotive industry, those in red are commonly used features for customers who are in automotive industry. First of all, we have the static analysis, where you can study assembly, parts analysis, and we can gain the minimum factor of safety, and so that we know what will be the high stress area in our design. Next, fatigue analysis, product lifespan. I believe is always a biggest concern in automotive design, because we do not want our design to fail during warranty periods, right? And the features again that like the most by most of the engineer and designer is this one: optimizations. Yes, let's say you have a design, and the software will automatically optimize the design based on your needs and requirements within the spec that you're given. If you are more on R&D on mechanical parts like engine compartments or simple mechanism to lift the booth or even the power window, you may consider the motions features as well, which is also available in SolidWorks simulation. More to advance, we have the linear dynamics, non-linear statics, and of course non-linear dynamics. Non-linear dynamics can be applied in rim testing. As I know, in the rim design, there is an impact test to fulfill as part of requirement. So non-linear dynamics allow you to perform this form of simulations. As a basic, as we all know, for us to perform a final element analysis, first of all, we need to have the CAD design, right? So we design our model in 3D, then we move our 3D model to the simulation interface, where we set up the final element analysis and we perform the calculations. So what we get at the end is an image in beautiful color, showing that there's a high stress, there's a low stress. Now this is a typical method. What we would like to propose in Solidworks is that we want to combine both CAD and FEA into one. So we see the FEA, the finite element analysis, as a features, because when you design the parts in 3D inside SolidWorks environments, at the same platform, at the same environments, you can immediately perform FEA, or we call the stress analysis study. Any design changes, immediately the setting will update and you just rerun to get a new set of data. So it saves you tremendous time on moving the parts out and reset all the final element again and again. So this is what we would like to share, and hope you accept that this is one of the good features for you to design better products. Last sharing, in part 1, we talk about assembly deformations and safety factors. You can see this is a simple assembly where we used for our sharing last week. It's a simulation for designer. It was so interactive between the design and validations, and easily you as a designer, you can understand how to make a better design. Talking about static analysis, so first of all, let's look at the image on the right. We have a chassis for Formula Student where it was completely built in SolidWorks using Wellman features, and from there you can see there's a stress analysis performed so that the student can study whether the frame is it safe enough for the driver. And in the bottom there's another assembly where you can see red color indicate high stress area. In other words, if the design to fail, the area in red have the most likely to fail. So static analysis allow us to check for stress and displacement for performance and quality so that we can avoid failure. And of course, we would like to decrease over dimensioning. As a designer, a lot of time we are not sure how far are we in optimized design. So static analysis will give us this kind of inputs. So mechanical resistance on parts and assembly, in other words, we call the factor of safety calculation. How safe is your design? So let's say the factor of safety is 2.5 we want to achieve. Definitely we do not want to get a result that's lower than 2.5 or too far away from 2.5 factor of safety, right? Yes. So let's look into one of the unique features that SolidWorks simulation offer in static analysis. We call the submodeling. Now you can see this chassis is quite complicated to match and run analysis. So what submodeling can offer is that first of all, we run a global analysis, means the whole structure is in, and then the result that we get from global analysis, we can localize it at the same single frame for us to obtain a more accurate result. So by diagram, this is how we work. First of all, a global result where we do what we call a draft meshing. We get a set of data and then we select components. So what happens next is that the global displacement are automatically transferred onto the border of the submodel, and from there we do a detail meshing at the submodel and we get an accurate result so that we can achieve efficient configuration comparison and a more detailed results, as I mentioned. So it's a very unique features, and I believe it will be very useful for automotive designer. Optimizations. Who can resist features that allow you to optimize your design automatically, right? So you can see the image there, before and after. So how it works is actually once you have the model in 3D, we can define which dimension allow the software to optimize and within the given spec. So let's say the factor of safety is 2.5, or I would say the dimension changes between 3 mm to 6 mm. So we have the design intent. The software itself will optimize the design and give us the result as what we want. So from this image, you can see that the overall percentage of reduction is from 24% to 34%. So optimization can help you find the best alternative, reduce time to market, reduce cost and weight, remain competitive, and of course to improve product quality. Now this video here showed how optimization in action in Solidworks. If you see the bottom here, we have the initial design and we have the optimal design as a comparison. Now come to fatigue analysis, predict design lifespan. Again, as an automotive part designer, we do not wish our part to fail during warranty periods, right? So these features allow you to predict how long will the product last, and it allows us to modify the existing design to extend working life. So let's say we give a warranty of 10 years. By basing on a unique SN curve for different materials, the software can calculate what will be the total life, the total damage, and the factor of safety of the parts. So with this, during the design stage, you as a designer, you can know how long, or you can predict how well will be your design work within warranty periods. Definitely, we do not wish there's any part to fail within warranty period, right? Okay, that's all the sharing for the finite element analysis. Let's talk a little bit more about flow simulations. When we're talking about flow simulation, first thing in our mind for automotive is Formula 1. Yes, very aerodynamic design, everything was well curved so that we can need the right amount of drag at the right time. We need the less amount of drag force if we need during the design. So what flow simulation can offer here is internal flow and external flow. A lot of time when we're talking about flow simulation, we as a designer, we just think about Formula 1. So how about internal flow? Yes, example like muffler design, like a valve design. All of this kind of study can perform in Solidworks flow simulations, as you see in the image in front of you. We also support both laminar and tubular flows, and if you need to study the thermal, yes, we can perform the thermal analysis as well. So first of all, internal flow. You can see this is a simple muffler design, okay, where from flow simulation it will show us the flow pattern when the flow coming into the muffler, how it tends to move and exit from the muffler. So from here, the color plot show the velocity, and it will allow us to know how much is the velocity drop in the muffler. Of course, as a designer, we will try to maintain the flow at a healthy rate so that the speed reductions of the moving gas is not too far from our expectations, right? This is internal flow. External flow, I'm not going to use any fancy aerodynamics Formula 1 car, but I will use something very common that we see every day on the roads. A tanker. Yes, a tanker. So first of all, you can see the pressure plot. You also can see the velocity plots, and the most important is that the arrow show a pattern of if there's any vortex, it will show us in the graphic. Now you can see at the end of the tanker here, you can see the amount of vortex and also the speed change of the air. So blue means low speed around 0. So this is the area that we create some suction. In other words, this will cause us to consume more, so that drive the lorry to move forwards. This is how aerodynamic for flow simulation can help us as a designer. This is a simple image of the plots acting onto the design. So enjoy a quick simple video so that for us to visualize the flow pattern in 3D. Now you can see at the behind of the lorry there's a blue color arrow indicating it's rotating. So this is a form of vortex that will create suctions, and you need to press more on the pedal so that your lorry can go up front. So this is how simulation, again, flow simulation, visualize something that we do not see in actual into the program, and we can see, and the designer know how can we improve the design. So for those who use wind tunnel testing, definitely you will know how will be the cost per testing. If possible, do you want to run the simulation in the software first, get your best design, then only you head down to the wind tunnel, right? So this is for flow simulation. That's end my sharing today for both finite element analysis and flow simulations, CFD. In summary, Solidworks simulation is tailored for designer, engineer to fulfill customer demand. Yes, I understand, especially in automotive industry, customer getting more and more demanding for simulation reports. Also, upfront design validation help you to reduce expensive actual testing. I believe those who do flow simulation, you will agree with me at this point, right? And not just that, even for normal parts designer, yes, it will save you a lot of cost on expensive testing. So for those who achieve better design, it allows you to optimize your design for weight and performance, and fatigue analysis allow you to avoid design to fail during warranty period, which is very important, because we as a consumer, we also don't like our car have any parts broken down within warranty periods. And again, I would like to emphasize that this is a very simple to use features that users see again it as a advanced features in Solidworks instead of complicated FEA, so that everyone can design better products. With this, thank you very much. I will open up a 2 to 3 minutes Q&A sessions. If you have any questions, do not hesitate to ask now, and I believe my colleagues will try his best to answer your questions.